All right. So today we will complete our discussion of vector equations for lines. What we have not discussed is equations for line segments. Let's say we consider 2 points, A and B. It could be in plane or space. And we want to find an equation for this line segment between A and B. How can we describe it? Well, again, we consider this using vectors. What do we want to do? We want to give an equation for this line segment, meaning that we want to describe a typical point, P, on this line segment. How can we describe it? Well, using vector notation, it will be very easy. So let's consider this vector AP from A to P. How is it related to the vector A to B? Well, it will be the vector AP, first of all, will have the same direction as AB, but it is shorter, right? So it will be a multiple of AB, meaning it will be T times AB, but this T should be between 0 and 1. Let's now write it more explicitly. So AP will be, this is our vector equation practically, A times P. Let's expand. AP is equal to, P vector P, position vector of P minus position vector of A will be equal to T times AB is B minus A. Again, T is between, however, 0 and 1. Let's take P by itself. So it will be, you see, we have 1A minus TA, 1 minus TA plus TB. With this condition, T is between 0 and 1. This would be our vector equation for this line segment. Take examples. Example, let consider A to be this point, B in space. Let's find a point between A and B on the line segment AB. Well, so here is A, here is B, and we want to find a point. How can we find P? We can use our equation. So such a point P will be that its position vector equals 1 minus T times A plus T times B, where T is between 0 and 1. Let's give some value. Put, for example, T equals 1/5. Why not? this will give me 1 point. Then P will be equal to 1 minus 1 over 5 times A plus T times B. So T is 1 over 5 B. Okay. This will be 4 over 5 A plus 1 over 5 B. You see these values T plus 1 minus T is equal to 1. And also 1 minus T is positive, right? Because T is less than 1. Okay. So it will be 4 over 5 times A. A is 1 minus 2, 3 plus 1 over 5. B. B is minus 2, 1, 5. Okay. So if you compute this addition, you will get a point P. This is 1 point. If you give other values to T, however, between 0 and 1, you will get other points. Let's take another example from the book. This example, exercise. So exercise 5 from page 67. This time we consider points in the plane. 1, 3, B, 2, 1, C, 4, 5. Okay. It asks the following. A, find the point P. It says AB. By this, it means a line segment, the line segment between A and B, such that the distance between A and P, this notation, you may remember, will be equal to 1 over 3 times B, the distance between B and P. Let's see how we find. How we find this point. Let's draw a picture. Typically, again, we have A, B. It says that find a point P in the line segment between A and B such that P will be here, that the distance between B and P will be 3 times the distance of A and B. Yes. So if this distance is D, this distance will be 3D. Okay. So what should be P? Well, we can try to use this description, or we can just think in terms of what we did here. So let's consider directly in terms of vectors. So let's consider the vector AP. So it will be a vector from here to here. if its length is d and the length between A and B is 4d, so it will be 1 over 4 times AB, right? AP is in the same direction as AB, so it will be a multiple of it, and the multiple will be its the ratio of its length. So it will be 1 over 4 times AB. Okay, let's now write the position vectors. P minus A will be equal to 1 over 4 times B minus A. From here, P will be equal to A plus 1 over 4 times B minus A. So it will be 3 over 4 A plus 1 over 4 B. You see? Similar to this one. So T is 1 over 4. 1 minus T is 3 over 4. But I did not need to remember this formula. So I just derived it here myself. Okay. Let's write it explicitly. So it will be 3 over 4 times A. So the point A is 1, 3 plus 1 over 4 times B. B is 2, 1. Okay. Then, let's see. So it will be, we distribute 3 over 4 plus 2 over 4. If I do this addition, multiplication and addition. And then we will have 9 over 4 plus 1 over 4. This will be equal to, you see, 5 over 4, 10 over 4. Okay. This is how we answer such questions, using vector notation. Let's consider other questions. So in this example, if you can look at your books, there are also other parts. So let's look at these parts as well. In the second part, it asks B, find a point Q on the half line from A in the direction of U C minus B such that the distance between A and Q is equal to 3. So let's answer this question. Okay, again, let's draw a picture. We consider here half line from A in the direction of U. So that is apparently that is this point A. And then you know C minus B, this is equal to BC. I guess there is also this point B, there is this point C generally. And then C minus B is called U, another name. All right. It is saying that point Q on the half line from A in the direction of U. So in the direction parallel to U. This is the half line. You know. Such that A times Q, so Q is here, equals 3. So this distance will be 3 units. Okay. All right, so let's write this equation. So I consider A times Q so this is such a point that it will be in the direction of U. So it will be T times U. However, T must be positive because it is in the direction. It is half line. Right? So the picture must be like that in the half line. T positive. And we want what? We want the length of this vector AQ to be equal to 3. I don't know Q, so let's now write this equation for Q. So, okay. Well, AQ is, you know, Q minus A. So Q, I don't know. I know A. A is 1, 3. Will be T times U. Do I know U? Yes. U is BC, C minus B. So let's compute C minus B. C is there, 4 minus 2. And 5 minus 1. 4. So T is, however, a positive number. So from here, let's find XY. XY will be equal to, we take 1, 3 to the other side. So we will have 1 plus 2T. And then 1 plus 2T. The other one will be 3 plus 4T. For some T positive. Okay. Again, I don't know XY yet, but I know that it depends on parameter T like that. Okay. Let's now write the distance between A and Q. Oh, this I did not need actually. Yeah, actually this is true, but this is something that I did not need. Anyways, so yeah, we were given the distance between AQ. So the AQ is here. So what is let's write the square of the distance between A and Q. So AQ is here. So it will be, the components will be x minus 1, y minus 3. So x minus 1 squared plus 1 minus 3 squared. This is equal to this is equal to x minus 1 squared plus y minus 3 squared. Yeah, by the way, so you see that from here. So what is x minus 1 and what is y minus 3? So x minus 1 is 2t, you see from here, so x minus 1, y minus 3 is equal to this one, so it will be square of 2t, the other one will be square of 4t. Because x minus 1 is equal to 2t, you see from this side. So x minus 1, y minus 3 is equal to this one, which is on the other side equals t times 2, 4. So this will be equal to 4 times t squared plus 16 times t squared. So this will be 20 t squared. This is to be equal to 3 squared, which is 9. Yes, from here, so we see that t squared equals 3 squared over 20. And from here, we get t as 3 over square root of 20, if I'm not mistaken in these calculations. And if we want to find q, we need to put this t in here. This will give me the point q. All right. So this gives us this required point. All right. That's all we say about points, about lines and their vector equations. Okay, let's now move to our new section. This is section 5.6, which is on planes in space. So we move one dimension up now. Lines are one-dimensional objects. Now we consider planes, which are two-dimensional objects, which may be new to you. So planes in space. Space we use with this coordinate system, x, y, z, as you know. And we want to find equations for planes. So planes, you know what a plane is. So plane is two-dimensional thing. So just like this paper extending in every direction. Okay. We want to find an equation. For this, we will use vectors as we did for lines. For this, let's compute. For this, we have the following notion, basic notion of a normal vector. So we use something called a normal vector to find equations. Normal vector, which we denote by n, generally, n, which is perpendicular to this point. So any vector, non-zero vector, n, which is perpendicular to the plane. So I try to show it, which is perpendicular. Plane P, let's say. Let's denote this plane P. Plane P is called a normal vector. Called a normal vector. For P, for this plane. This is similar to direction vector. 4 lines. For lines, direction vector was, if you remember, parallel to the line. However, here we use a vector which is perpendicular for planes. Okay, now using this, we can find an equation for this plane. So let's say, oh, by the way, there is not only one normal vector, there are infinitely many, right? Just like we did not have single direction vector for a line, we do not have a single normal vector, but many vectors, normal vectors. All right, let's now suppose that we know a point P0 on the plane. Using this, we can write an equation for this plane. Okay, so first let's notice the following. So in this picture, so plane, there is a point P0 passing through P0 and perpendicular to N. There is only one such plane. There is a unique plane in space which passes through this point P0, through P0, and perpendicular to N, this vector, normal vector that we called. Okay, then what is the equation of this one? This will be very easy. Again, let's look at this picture. So this is the point P0. And again, let's consider a typical point, P. Writing an equation means describing the general points on this plane, P, on the plane. So I'm going to describe now a general point P. How can I describe? For this, let's consider this vector P0P. Well, so what will be special with this vector P0 to P? So this vector will be on this plane, obviously, right? So if this is the plane, you see, if this is the plane, so this P0P will be a vector that lies on this plane. And so on the other hand, this plane is perpendicular to N. Therefore, this vector will also be perpendicular to N. Let's write it. Then I consider this vector P0 to P. This will be perpendicular to N, which means that is perpendicular to N, which means that dot product is 0, if you remember. Okay. All right. So you see, we already have an equation now. This is an equation, right? Which describes this unknown point, this general point P. I know P0, and I know N, so I should be able to write this one as an equation for the plane. Okay, let's now write it more explicitly. So let's call P0, this point P0, its coordinates, let's say, are x0, y0, z0. Okay, Now, there is also this vector n, this normal vector. Let's also say its components are A, B, C, okay? And there is this P. P is general point, X, Y, Z, which we don't know. Any point on the plane. Okay, let's now expand this dot product. P0P, what will be components of this vector? It will be X minus X0, Y minus Y0, Z minus Z0. Dot product, N. N is this vector A, B, C. And we equate the dot product to 0. All right. Compute the dot product. You know what dot product is. Plus C times Z minus Z0 equals 0. So you see that we have an equation here now, equation in terms of x, y, z, right? There is no parameter like t, just like we had for lines. All right, let's now expand this one, if you like. Ax plus by plus cz plus, there will be this constant term, minus ax0 minus by0 plus, not plus, minus c times z0 equals z. All right. Okay. Let's take an example, if you like, to see how this equation looks on a concrete example. Example, find an equation of the plane of the plane. By the way, I got an equation, fine. However, you see it depends on the normal vector. So if I choose another normal vector, I will get a different equation. But they will be related, as we will discuss later. Okay. Find an equation of the plane which passes through the point P0, whose coordinates are 1, 2, 3, and perpendicular to the vectors n equals minus 2, 1, 5. All right. We will proceed as we had before. Again, let's draw a picture here. So plane is something like that, two-dimensional. Yeah, plane is like that. Okay. What do we know about this? So it passes through this point P0, and it is perpendicular to this n. So n is normal vector, right, for us. So it should be perpendicular. Okay, let's write the equations. So again, I consider a typical point P here. And I consider this vector P. Now, the thing is that this, and when I consider the vector P0 to P, this will be perpendicular to this n, and the perpendicular means for us the dot product is 0. I write this dot product. Okay, let's now expand this one again as I did before. So P is now x, y, z. P is general point. P0, P will be its components. Okay. Dot n. N is normal vector. This vector. This should be give me 0. Okay. Then now I distribute minus 2x plus 2 plus y minus 2 plus 5 times, I distribute again 5z minus 15 equals 0. So I get minus 2x plus y plus 5z, and then, so I have two constant term, I have coming 2 minus 2, which will be 0, and then I'm going to have minus 15 equals 0. Okay. So this will be the equation of our plane. And you see this is called a linear equation. So you see we have x, y, and z. Just first degree equation. There is no squares or anything. There is no other parameter t. So this would be the equation. Okay, so let me draw your attention to something. So in general, as I said, the equation of a plane, when we write it out, finally, the final form of the equation will be like that. And you see in this equation, so there will be x, y, and z, so first degree terms. And you notice that the numbers in front of these x, y, and z are going to be the components of the normal vector. Remember, what was ABC? ABC were components of the normal vector. So the numbers in front of x, y, z will always be components of the normal vector. And we will have some constant term. So you see, this constant term depends on A, B, C, and also it depends on the point x0, y0, z0, right? So if we use, you see, a different point, P0, on the point, this constant term will change. However, this normal vector will be the same if we use the same normal vector. So let's look at this also in here. You see, this normal vector had components minus 2, 1, 5. So they show up here as coefficients of these variables x, y, z. So we have minus 2 in front of x, as we had here. And there is 1 in front of y, which is the 1 here. And there is 5 in front of z, which is the 5 here. Okay. And then there is this constant term, minus 15. Well, why do we have minus 15? Because I'm using this point, 1, 2, 3. If I use a different point, I will have another number here, but fine. Sorry, I must say that if I use another point and another normal vector, because you see this constant term comes from, also includes A, B, and C. Not just x0, y0, z0, but it also includes A, B, and C. Okay. However, you see in what I'm saying is that in front of x, y, z, there is only the normal vector show up. There is no, this P0 does not appear. Okay, any questions? All right. Well, let's continue with this example. So we have computed 2x plus y minus 2x plus y plus z. We don't need to memorize these formulas, but the shape of the formula would be useful to keep in mind. So our formula, typical formula for the planes will be like that. Ax, by, cz plus something equals 0. All right, let me ask more about this plane. So let me ask you to find two other points on this plane. Let me say B. Find two other points on this plane. Points on this plane. Plane is here. I already know P0. Let's find how other ones. So how can we find other points? Very easy. So I can give some values to x, y. Then I can find the z value. This way I will get a point. For example, let's put x equals 0, y equals 0 in this equation. Then what do I get? X is 0, y is 0. Then I will get 5z equals 15. So I will get z equals 5. So let's call this point P when x is 0, y is 0, 5. This will be a point on this plane. Why? Because it satisfies this equation, right? So let's call this one P1. So a point will be on the plane if and only if it satisfies the equation. And by its construction, these numbers satisfy this equation. So this point must be on the plane. Similarly, we can put other values. If we put other values to x, y, then you get other numbers. For example, for convenience, I put x equals 0, z equals 0. Then what do I get? X is equals 0, y equals 0. Then I'm going to get y equals 15. So what point will be on this plane? So the point when x is 0, z is 0, y is 15. This is also on this plane, this point. Okay. Let's find other points. Let's consider putting y equals 0, z equals 0. Then what will be x? X will be minus 15 over 2. So let's call this one P2, this one P3, minus 15 over 2. Y is 0, z is 0. This will be also on this plane. And we may continue. You can put any number you like. You can put x equals 3, y equals 5, z equals minus 95. Then you will get a point on this plane. So this way you can get many points on this plane. However, you see these points that I have computed here will have some specialty. So these points will be special points.
Hocam
Yes.
yukarıda işlem hatası yaptınız galiba da Z'ye 3 olması lazımdı.
Where?
İlk X0, Y0, Z5 yazmışsınız
Oh
ama
yeah.
3
When x is 0, y is 0, z is 3. Okay. All right. So these, however, these points will have some meaning. Yeah, this is our equation. So let's try to draw the picture of this plane more correctly as much as we can. So let's locate these points. So these points are as follows. So when x is 0, y is 0, z is 3, meaning that, and the point 0, 0, 3 is on this plane. So where is this point on this picture? On the coordinate system, x, y, z. So this point P1 is, you see, on the z-axis. So the point I computed P1 is going to be what point? Intercept. So it will be z-intercept of this plane. Similarly, let's put x equals 0, z equals 0. Then y is 15 will be on the y-axis, right? So let's say P2 will be in here. All right. Now, yeah, I'm looking at this one. Similarly, y equals 0, z equals 0, x is minus 15 over 2. So it will be on this side, somewhere here. Yeah, unfortunately, my scaling is not so good. So x, this will be, P3 will be here. So you see, my plane will be what? Something like this. So it will be shape. So I'm going to have a triangle here and continue this way. So my equation will be, so my plane will have such a and it extends in all directions in a way that it will be perpendicular to n. All right. Yeah. So these points are kind of special points. They are the intercepts of this plane. So these are the intercepts. Of the plane, where they intersect the coordinate axis. Okay. Well, so we will take more examples. But let's give a 5-minute break if you like. All right? So let's now give 5-minute break. Okay. So I will be back in 5 minutes. Evet, herkes yerinde duruyor değil mi? Evet arkadaşlar, anlıyor muyuz? Nasıl gidiyor? Ses verecek yok mu?
İyi gidiyor hocam bence.
Anlıyor musunuz?
Anlıyorum ben.
Anlıyoruz hocam.
Evet,
Evet hocam,
Efendim? Sıkılıyor musunuz?
sıkıntı yok.
Sadece son saatler olduğu için biraz yorucu oluyor hocam.
Evet, ben de farkındayım. Bu uzaktan eğitim çok mu kötü? Ne kadar kötü normale göre? Kıyaslayabiliyor musunuz?
Aşırı kötü hocam.
Efendim? Sesler karıştı.
Çok kötü bence hocam.
Çok mu kötü?
Bence güzel aslında.
Yani bana da çok kötü gelmiyor aslında. Yani belki
Hocam bu şekilde senkron işlenen dersler güzel. Mesela şu an siz tahtada anlatıyorsunuz ama
evet.
derslerin ses sıkıntısı, sonra yazdıklarını okuyamama vesaire çok fazla oluyor. O yüzden kötü bence.
Evet.
Hocam bir de sınavlarda sorular arası geçiş olmaması kötü oluyor. Hani normal sınavda istediğimiz sorudan başlayabiliyoruz ya.
Evet, evet.
Sınavlarda geçiş olmaması, mesela ilk sorular zor geldiğinde hani vakit kalsın diye onları boş geçip sonra yapınca geri dönememek kötü oluyor.
Anlıyorum ama yapacak pek bir şey yok çünkü o kopya çekilmesin diye yapılıyor. Yani zorlaşsın diye de. Ama doğru, sizin için dezavantaj.
Az mı? Mesela ben 260 da alıyorum. 260'da 5 soruya 80 dakika vermişlerdi. Ama
Evet.
analitikte 10 soruya 70 dakika verildi. Yani süre biraz az geldi bana.
O 260'ta geri dönebiliyor muydunuz?
Geri dönülmüyordu yine ama süre yeterli olduğu için hani sorular üzerine uzun uzun düşünebiliyorduk.
Hızlı yapmaya çalıştığımızda işlem hatası da çok oluyor hocam. Normalde yapabiliyoruz sorular ama hata yüzünden giden sorular da çok fazla oldu.
Evet, biz mümkün olduğunca yani işlemi az olacak şekilde sormaya çalışıyoruz ama bazen çok ayarlayamayabiliyoruz. Haklısınız, doğrudur. Yazımı okuyabiliyor musunuz peki?
Evet hocam.
Evet. Peki tahtada mı anlatmak size daha uygun geliyor yoksa bu tablet üzerine yazanlar mı daha şey?
Tahta bence.
Tahta mı daha uygun?
Bence de tahta hocam.
Bence de tahta.
Tablet
Bence
uygun
de.
diyen var mı? Evet. Evet. Bunda da videoyu paylaşıyoruz ama videoyu hızlandırabilirsiniz. Evet. Evet. Yok ben kaydını koyduğumuz için gerek duymadım ama kaydını şey yapabilirsiniz. Şimdi ben soruyu yazarken bir sürü zaman geçiyor. Mesela kaydını izlerken o yazma kısmını ileri sardırabilirsiniz. Yani çok o kadar. Evet. Evet, iyi bakalım.
Hocam herkes aslında hani bütün hocalar böyle yapsa dersi uzaktan eğitim süper olacak da
Evet.
öbür türlü bir ders atıyorum yani neyse. Şimdi kötü olmaz.
Bir ders. Bir ders tablette bir ders böyle garip mi oluyor?
Yok yok hayır yani mesela 111'de sabahleyin hocanın kullandığı bir tane mikrofon biraz kalitesizdi. Yani
Evet.
kamerası da gitti bir ara. Artık bir yerden sonra tahmin etmeye başlıyoruz. Hani acaba ne demeye çalışıyor diye.
Ha, evet,
Ekipmanımız var aslında ama
evet,
derse dinlememek koyuyor.
evet.
Bu
O
ama
ders
var
burada
şu
mı
an.
çekilmiş?
Yok, o mesela o hoca evinde çekiyordu.
Evinde çekiyor. Ha, evet. Ona bir şey diyemeyeceğim, evet. Efendim? O konuda bir şey duymadım ama herhalde düşük ihtimaldir. Öyle bir şey duymadık.
Hocam bu soru hakkında
Elbette, elbette, tabii ki. Ama pek mümkün görünmüyor şu anda yani. Evet, siz ne başka?
hocam bu konu hakkında bir şey sorabilir miyim soru hakkında?
Tabii.
P1, P2, P3 noktası nasıl kesişti?
Onlar kesişmediler. Onlar şey, koordinat eksenleri üzerinde noktalar. O doğru plane, yüzey onlardan geçiyor. Kesişmediler onlar.
Anladım, tamam. Teşekkür ederim.
Onları ben birleştirdim. Birleştirince bir üçgen oluştu. Onu mu diyorsun kesişim diye?
Evet, aslında onu demek istemiştim.
Ha, yok, o düzlemin yani evet. O oktantta yani o kısımda arkada kalan parçası. Şimdi bu şekil olarak arkada olduğu için o nokta negatifli çıktığı için tam şekil görünmedi. Ama şeyde olsaydı daha kolay olurdu. Bak şöyle çizeyim istersen. Eğer bu noktalar şöyle çıksaydı, bu doğru mu yüzeyimiz plane bu noktalardan geçecekti. Yani böyle de devam ediyor da ben şurada kalan kısmı üçgen oluyor yani. Şöyle yani. Şu plane böyle gidiyor. Benim kastettiğim noktalar bunlar. Bunlar noktalar kesişmez zaten. Noktaları ben birleştirdim doğruyla bir üçgen çıktı. Yani şu parçada kalan kısmı bir üçgen oluyor şu kısım. Ama böyle uzayıp duruyor sonra.
Tamamdır hocam, teşekkür ederim, anladım.
Efendim?
Teşekkür ederim, anladım.
Tamam. Tamam, o zaman şimdi şeyimize başlayabiliriz. Tabii buna İngilizce devam etmemiz gerekiyor. Okay, so let's compute more equations. For example, we may ask, find the equation, or an equation actually. Find an equation. There is not one equation. There are many, but they will be related, as I will explain later. Find an equation of the plane passing through the points P1, 1, 2, 3, P2, -2, 1, 4, and P3, 1, -1, 5. Well, we know that if we are given 2 points, distinct points, there is only one line passing through these points. Similarly, if we have 3 points, then distinct points, then there will be, actually we have some restrictions later, there will be, most of the time, a plane, unique plane, passing through these 3 points. Okay. So let's draw a picture here again. So these are points, P1, P2, P3. And we want to find the equation of the plane that passes through these points, P1, P2, P3, which is a very natural question. Okay. How do we find the equation of this plane? Just like we had previously. So you see, to write such an equation, we need two things: a point on the plane and a normal vector. So here we have not one but 3 points on the plane. So we only need a normal vector. So let's find a normal vector. Normal vector will be a vector which will be perpendicular to this plane. So how can I find a vector which is perpendicular to this plane? For this, I may consider the following. So you see, when I have these 3 points, P1, P2, P3, then I can form these vectors, P1 to P2 and P1 to P3. So these vectors will be on this plane, I can think. All right? Then, well, if I find a vector which is perpendicular to both of the vectors P1, P2 and P1, P3, then it will be also perpendicular to n, all right? So, and I know, how can I find such a vector perpendicular to both of these vectors? Well, we immediately remember when we hear the term perpendicular, the cross product. So cross product is such a vector. Cross product of these two vectors will be perpendicular to both. So it will be perpendicular to this plane. N. Okay. All right. So let's compute this vector, normal vector. For this, let's compute the components first. So components of P1, P2 will be P2 minus P1. So it will be minus 2, minus 1, minus 3, 1, minus 2, minus 1, 4, minus 3, which is 1, cross P1, P3, P3 minus P1. So 1 minus 1, 0, minus 1, minus 2, minus 3, 5 minus 3, which is 2. Okay. Let's compute this cross product, meaning that we will compute this determinant, minus 1, 1, 0, minus 3, 2. So let's expand this one. So I times minus 1, or let me compute it directly. So it will be I times this determinant, which will be minus 2 plus 3, which will be 1. So it will be I minus, I'm going to have j. So the determinant will be minus 3 times 2 minus 6. There is also minus in here. So it will be plus 6j. And then k. So I will have minus 3 minus 3, which is 9. It's 9k. And the components will be 1, 6, 9. Okay. So I have found this normal vector 1, 6, 9. Okay. Then what will be the equation like? Okay, so again, let's consider this typical point P. P, and I want to write the equation. So I can use this point P1. So let's compute P1P, for example, dot n equals 0, where P is typical point X, Y, Z on the plane. All right. So P1P will be X minus 1. P1 is 1, 2, 3. Y minus 2. Z minus 3. Dot n equals 0. Okay. Then I'm going to have, n is 169. Okay, from here, I'm going to get x minus 1 plus 6 times y minus 2 plus 9 times z minus 3 equals 0. Okay, let's expand this out. So x plus 6y plus 9z. And then, so you see, minus 1 minus 12 minus 27 equals 0. So I have minus 1 minus 12 minus 27. So this will be minus 11 minus 38, I guess. 6y plus 9z minus 38 equals 0. Oh, so it must be 40, pardon. All right, so you see, this is the equation we get, x plus 6y plus 9z minus 40. Okay, so you see, the crucial thing is obviously to write this one, right? Finding the normal vector and finding this one. And also you may note that this normal vector 169 appears in front of x, y, z here, right? So there is 1 in here, 6, 9. Okay, well, also, you see in writing this equation, I used the point P1. In fact, I could have used another point. So let's write the equation using P2. Right. So we may use P2. Let's use P2 as well. So P2 P dot n equals 0. This would also be an equation, right? So let's write this equation. So P is x, y, z minus P2. P2 is here. So it will be x plus 2, x minus minus 2, y minus 1, z minus 4, dot n is 169 equals 0. And let's expand this out now. So I'm going to have x plus 2 and then plus 6 times y minus 1 plus 9 times z minus 4 equals 0. So from here we get x plus 6y plus 9z, just like we expect, right? Plus, all right, let's see what we will get. I have 2 minus 6, 9 times minus 4 is minus 36 equals 0. And again, so this sum is going to be minus 40. So x plus 6y plus 9z minus 40 equals 0. Yeah, you see I got the same equation. Right? Interesting, right? Because the reason is that there is no difference between P1 and P2. They are both points on the plane, and also I'm using the same normal vector. And as I said, this normal vector always will appear as coefficients in front of x, y, and z. So whatever point I am using in the equation, I'm going to have x plus 6y plus 9z, definitely. And then the remaining part, however, well, the remaining part must also be the same, because in this equation, you see, x plus 6y plus 9z will be equal to, as numerical value, equal to this minus of this constant term. So we will always get the same equation. All right. Okay, so after this remark, let me ask you one more question about this one. We have this plane equation. So let's find, so this is a plane in the space, three-dimensional space. So part B, find the intersection of this plane, the intersection of this plane with the xy plane, coordinate plane, with the xy plane. Okay, so you know what xy plane is. Xy plane is x, y, z. Let me erase this part. So this x plus 6y plus 9z is a plane in space, so it is going to intersect. Where is it going to intersect this xy plane? So it will be something like that. So you see, it will intersect somehow. So what will be this intersection? Let's talk more about this one. Okay, so how do I find this intersection? This intersection. It will be what? It will be the set of points which are on this plane. So the points satisfying this equation, and which are also on this xy plane. So you know xy plane is this one, perpendicular to z. So what type of points are these? So they are the points where z coordinate is 0, right? So xy 0, okay. So we get, if we put z equals 0 in this equation, what do I get? X plus 6y equals 40. What is this one? X plus 6y plus 40. What is this equation? What is it here, right? Well, since we have z equals 0, now we consider this. We should consider this equation in the xy plane. And what is it describing in the xy plane? You know, this describes a line in the xy plane, right? So let's draw this line. So x will be equal to 40. Y will be, I find the intercepts of this line. Y will be 40 over 6. 40 over 6. Okay. And yeah, so the intersection will be a line, something like that. So our plane will be intersecting this xy plane along this line. So it will be like that or maybe like that, depending on this normal vector. So it will be something like that. Yeah. So the intersection will be line in the xy plane. It will be the line whose equation in the xy plane is this one. XY plane. Okay. Let's now discuss. Now, speaking of intersections, let's discuss now how we find intersections of planes. So, you know, when we have two lines intersecting, typically, they will intersect along a line. So, you see the picture will be like that. So let's say this is one plane. And if we have another plane, so typically they will intersect along a line like that. Right? So it is natural to ask how we find these intersection lines. Let's consider find the equation of the line, which is the intersection of the planes. Two planes I will give P1, whose equation is like that, plus 2y plus 3z plus 4 equals 0, and P2, x minus 2y plus 2z plus 1 equals 1, 0. All right. Two planes, and we want to find the intersection, which is going to be a line. Okay. Solution. Well, what do we need for the intersection? So let's denote this intersection by L. So to write this, the equation of this line, we need two things, you know. We need a point on the line and we need a direction vector. So let's first find the direction vector. So how can I find direction vector? So by definition, you know, direction vector is a line, is a vector, pardon, parallel to the line. So how can I find such a vector V? Well, so we can think of, you see this vector V will be parallel to this line. So you see, it will be parallel to both planes because it is in the intersection, right? Therefore, it will be, if we think in terms of these normal vectors, it will be perpendicular to these normal vectors, both normal vectors. So we can take V, so any vector perpendicular to both normal vectors. So N1 cross N2 would be a direction vector. So will be a direction vector, will be a direction vector for L. Let's compute this direction vector now. So N1 is normal vector for P1. So how can I read a normal vector from this equation? I'm looking at the numbers in front of x, y, z. So 1, 2, 3 will be a normal vector for P1. Similarly, 1 minus 2, 2 will be a normal vector for the second plane. Okay. And their cross product will be a direction vector necessarily for V. So let me write it directly. You can compute it yourself. 10, 1 minus 4 if it is not mistaken in here. Okay, so this will be direction vector for L. All right. Now, to write the equation of this L, we need a point on it. we will write this vector equation, just like we learned last week. Let's now compute this point. So how do I find a point? To find a point P0 on this plane, on L, what do I need? So I need a point which satisfies both equations. So P0 will be, you see, P0 will be on this line, but line is the intersection. So P0 is find P0, X0, Y0, Z0 that satisfies both of these equations. X plus 2y plus 3z plus 4 equals 0, and x minus 2y plus 2z plus 1 equals 0. Okay. So we need a point x, y, z satisfying both equations. Well, how can we find such a thing? You can find it in any way you like, but one way to do could be the following. So I have 2 equations and 3 unknowns. Anyway, so let's put z equals 0. I put z equals 0. Then what will be my equations? So my equations will be like x plus 2y, z will be equal to 0. So x minus 2y plus 2z, pardon, z becomes 0 already, equals 0. Okay, so I suggest to take the sum of these 2 things, adding these 2 equations. What do I get? Y's disappear. So we have x equals minus 5 over 2, you see. And if x is equal to minus 5 over 2, so plus 4 over 2, we will have y equals minus 5 over 2 plus 2 over 2, 3 over 2. So y equals minus 3 over 4. Okay, so I got xy given z equals 0, doesn't matter. I put, but it doesn't matter. So this shows the following, that the point whose x coordinate is minus 5 over 2, y coordinate is minus 3 over 4, and z coordinate 0 will be on L. On L. All right. Okay, so I got my point on the line. I got already also the direction vector. Now I can write the vector equation for L. So vector equation for L. Remember, vector equation for L will be to describe a typical point P. Remember, our way is the following. We were looking at this vector P0 to P, which will be a multiple of V. So it will be P0 P equals T times V. Now we can expand this thing, where P is X, Y, Z, a typical point on the line. Let's write components. Components of P0 P will be X plus P minus P0, so it will be X plus 5 over 2, Y plus 3 over 4, and Z minus 0 equals T times V. V is 10, 1 minus 4, okay. And then if you say that okay, x equals minus 5 over 2 plus 10t, y equals minus 3 over 4 plus t, z equals minus 40, you can write these symmetric equations. So this is it basically. Then you can write, parametric equations. Parametric equations, etc. All right. And this is how we find intersection of two planes. This is always the same. If you have two planes intersecting along a line, then you can just find the direction vector by taking the cross product of the normal vectors. Then you find a point, any point you like, P0 on the line, just like we had here, and then you write the vector equation. And then you can convert it to parametric equations or symmetric equations. Okay, so next time we will consider more examples regarding the intersection of planes and also their positions with respect to each other. So we will learn in particular how to find angles between planes. And it will be very easy using vectors. Okay, so we can stop here, and the next time we will continue. We will continue with more examples. Okay, that's all for today. Thanks very much for attending. Evet. Bu kadar arkadaşlar bugünlük. İyi akşamlar.
İyi akşamlar hocam.
İyi akşamlar hocam.
İyi akşamlar hocam.
Teşekkür ederiz.
Ben bir noktada takıldım da sorabilir miyim?
Efendim?
Bir noktada takıldım da sorabilir miyim?
Sorun anlamadım.
Bu noktada -2 olması gerekmiyor mu? 2 yazdık.
Olabilir, yanlışlık olabilir. Nerede?
N2 vektöründe.
N2'de mi? Doğru,
Evet.
yanlış olmuş. Evet, orası -2 olacak.
Tamam. Ona göre de işlem değişiyor sanırım değil mi? -1 olacak.
-2 belki ama cross product doğrudur. Ben başkasına bakarak yazdım ya. 1 -2 olacak burası. Doğru.
Anladım.
Evet.
Hocam ben de bir şey sorabilir miyim?
Tabii ki.
Z'yi neden 0 seçtik? Yani öylesine gelişigüzel mi seçtik?
Evet, gelişigüzel.
yoksa-
Öylesine
Evet.
ben işlemi çözmek istiyorum ya x, y, z.
Hı hı.
Çözümü z eşittir 0 olan çözüm aradım. O yüzden z eşittir 0 koydum. Kolaylık olsun diye, ama başka bir sayı da koyabilirdin. Veya x yerine başka bir sayı koyabilirdin.
Tamam hocam,
Y
anladım.
yerine de. Önemli olan bunu sağlayan herhangi bir tane
Hı hı.
çözüm bulmak. Yoksa hepsini bulmak derdinde değiliz. Herhangi bir tane. O yüzden sen istediğin gibi bir yerden başlıyorsun. Bir değer veriyorsun. Birisine bir değer veriyorsun. Diğerlerini ona bağlı olarak buluyorsun.
Tamamdır hocam, teşekkürler.
Evet. Evet, başka sorumuz varsa onları da cevaplayabiliriz.
Hocam ben de sorabilir miyim?
Evet.
N1 cross N2 hani V vektörüne eşit oluyor dedik ya. Neden V'ye eşit oluyor?
Eşit olmuyor. Ben M1 cross N2'ye V dedim. V de paralel, L'ye paralel bir vektörü gösteriyor. Yani bu cross product o kesişimdeki doğruya paralel bir vektör olacak. V'ye eşit çıkmıyor. Yani V diye bir şey yok baştan.
Tamam hocam şu an.
Ona V dedim.
Tamam hocam, teşekkür ederim.
Evet. Evet, başka soru yok herhalde. Burada bitirebiliriz.